Welcome to another episode of libGDX-Graph devlog. In this episode, I'll show you how to use full screen shaders. And as an example, I'll show you how to start off working on a shader like this. That basically makes your whatever you're drawing in your pipeline turn into something that looks like it's on the screen of an old monitor, CRT monitor. You can modify the distortion that is produced by the monitor, and as well you can turn it off and on full screen shader. So I start off with this very simple graph that has graph shaders here and the UI, and I'll add here a new entry here inside of the pipeline submenu, which is full screen shader. The difference between graph shaders and full screen shader is that full screen shader is basically the shader that's being created here is responsible for drawing every pixel on the screen, or drawing on top of every pixel on the screen, because you can use this as an overlay as well. As you can see, it has a tag here, so I'll create a CRT monitor tag. That's how I refer to this shader inside of in the code and the example here. Also create a new boolean here, property, and call it distort. And attach this boolean property to the enabled full screen shader input. I'll now modify the shader to make it draw a white color. And if I run the application, I start with this spaceship here being rendered, and if I'll enable this, I'll change the property distort to true. I'm just drawing a white screen on top of it. So, okay, so of course you can attach camera and graph lights, the lights here. It is not necessary for this specific shader, but for other shaders where you might be using these things like camera and lights, you might want to pass this here and then use it inside of the shader. Okay, so let's start with doing something what we want to do on here. So I'll start off with getting the scene color, so whatever was drawn before, and I'll sample it. At the moment, I'll just sample it with the screen position. Note that in case of the full screen shader, you don't have material or attributes available because there is no actual model instance being passed to it. At least you're not passing it yourself, therefore this stuff is not available. You only have anything else but anything related to a model itself. So I've changed, as you can see here, that scene color by default in the preview is this black and white checkerboard pattern. That is to make it easier. So if I now save it and reload this example here, it will just draw the same thing because I'm just copying whatever that was drawn before onto the buffers on the screen. So what I want to do here now, I want to squish it vertically and horizontally to fit onto the so-called screen. So let's start with, I'll attach the screen position. I'll be using it here. So first of all, I'd like to normalize the data. So the screen position is in the range from 0 to 1, left to right, and 0 to 1, top to bottom. I'd like to have it be in a range of -1 to 1, because it's going to simplify my math here. So I'll first of all, from the screen position, I'll subtract a constant of 0.5. That will turn the ranges to be -0.5 to +0.5. And then to move it to a range of -1 to 1, I'll have to multiply it by 2. So constant 2. Okay, now let me just group these things together and name them screen position in -1 to 1 range. Okay, now that I have it, I will split the values first of all into X and Y. So use the path value split. And I'll also calculate an absolute value of both of these. That will give me the screen position in 1, 0, 1 range. So name it here. 1, 0, 1 range. Okay, so it's really visible. But yeah, so this is what it is. Now that I have it, so what I want to do is I want to modify the x by the size of the y and y by the size of the x. So basically cross the x and y's here. So I'll first of all split the absolute values into x and y as well. Maybe I'll just rename these two. In position in -1 to 1 to -1 to 1 to 0 to 1 range. Okay, this fits better. And so then I will multiply the x and y from here separately. So I'll have two multiplies, one for x and one for y. One for x and one for y. And I'll multiply them by a new property that I'll add here. It's going to be called load property distortion, which will basically modify how much I'm distorting the screen, so how more rounded it looks rather than square as we have normal monitor. So we start off with this, multiply, and then on top of that I want to, so this is going to be in the range of that. So I want to now add 1 to each of them. And that is because this value is going to be between, this is between 0 and 1 basically. This is going to be between 0.2 and 0 and 0.2, and I want to make them into something closer to 1, so I'll add a constant here, 1. And the same for the y coordinate. Reuse the 1 in here. I'm going to reuse the property here, the distortion. And now I'll multiply these values by the value of y and x in the opposite direction. So whatever is the x here is going to be multiplied with the result of y here. And whatever is the y coming in from the values multiplied by x. So what this means is that the x coordinate in the -1 to 1 range is going to be multiplied by value that is depending on y. So the further away the y coordinate is from the center of the screen, from the 0, the larger this value is going to be. So it's going to be 1.0 by default, and the further away is going to be going to 1.2 in this case, because the distortion is 0.2, but if I want the price, it's going to be, so basically the x is going to be multiplied by y, how far, depending on how far it is from the center of the screen, and same for the x. And now I'll merge these two values. X and y, and use the vector 2 as the UV into the color texture. Okay, this is of course wrong. The problem is that these now are returning negative values. I want to have them be always between 0 and 1, because that's what the sampler accepts. And the reason because they are between -1 and 1 is because of this, or actually more than -1. It's -1.2 to 1.2 range here. So I have to bring them back into 0, 1, I have to multiply them by 0.5 and then add 0.5. So math multiply and then math add. And I'll have a constant here, 0.5. Multiply by 0.5, then it's going to be bring it to minus 0.5 to 0.5. And then add 0.5 is going to be 0 to 1. Now if I attach it, okay, now we are seeing that we are seeing kind of a squished screen, and depending on the distortion size, the difference is going to be smaller or bigger in what we are seeing here. So that's a good start, but however, I would like these to be more rounded. At the moment, as you can see, this is like basically a lines being drawn on the center lines of the screen. To do that, I actually will, when I use this absolute value of x and y, instead I will raise them to a power. I'll probably start with power of 2 here. So I have math exponential power. I have to do it separately. So exponential power. So x is going to be raised to the power and y is going to be raised to the power. And instead of these, the result of this will be multiplied. So I'll create a constant here for the power. This is one of the things that you can modify, have more rounded or less rounded output. If I use this now, save it. As you can see, this looks more rounded. It's not like straight lines here. Okay, now so we fixed the shape of it now. However, what is next is I'm missing here. Yeah, that's more like it. Yeah, because the y was not rounded. Okay, so what I'm missing now is, first of all, I want to so we have this stretch here, the texture is being stretched here. I want to cover it up. So the way I cover it up is if the output of this, so this is basically a screen position to use. Start from here. Screen position to read. Okay, so as you can see, we are reading the screen position of here, the texture. So what I want to do here is, if this value is less than 0 or greater than 1 in either x or y direction, basically this means we are hitting a border and we don't want to go there. So what I'll do here is I'll split the value into x and y because I have to look at them separately. There probably are some ways that you can modify this. Actually, no, I'll subtract the 0.5 from it once again to be able to get where the middle of the, to normalize it on -1 and +1. So constant 0.5 again. Then I will absolute value it because both x and y is going to be the same now. So once I calculate absolute value of this, I will get the, if anything is greater than 1, because, sorry, greater than half, it is a border. Because first of all, I subtracted 0.5, so 0 to become -5, 1 becomes 0.5, so -0.5 and 0.5. And then after doing absolute value, anything that's above 0.5 is a border. So what I'll do here is I'll use the step function. Actually, I'll use two-step functions because I have to look at separately at x and y. After splitting this, x and y, sorry, x and y to input edge, and edge is going to be 0.5, because anything above 0.5 is a border. Load 0.5 is a border. So if it's greater than 0.5, this is going to be 1. And this is greater than 0.5, is going to be 1. So I'll multiply those two values. So the output is going to be 0 or 1. It's going to be 1 only if both of them are 1. However, I don't want that. I want to have them if either of them is 1. And to do this, or either of them is true. So to do that, I'll instead do 1 minus. So basically, I had values here of anything that is above 0.5. I want to be able to it as a border. And if I reversed it, then anything below 0.5 is a border. So when I multiply this, I'm going to get let me think. I'm going to get 1 if both of them are, if either of them is 0.5. So I'll use here a lerp, and instead of passing the color directly here, I'll introduce a constant color of black and use this instead. I think that should give me the correct, no, that's the opposite. Okay, so I have to switch those two. Okay, so now we have borders already found. So let's call this big thing border detection. But so what I'll do next is I want to add this kind of overlays showing that, like the horizontal bars passing on the screen. The way I'll do this is I'll once again use the same position that I'll be reading. I will split it into x and y, and I'll pass it into a sine function, but only the y because I want the bars to be horizontal. And then I'll make it into a step of 0. So anything below, so if the sign is below 0, it's going to be fine. If it's going to be above 0, I'm going to make the color a bit different. So math common step, I'll set an edge to 0. So if the sign is below 0, this output of this is going to be 0. If it's above, it's going to be 1. And I'll multiply the output of this by some small value. So this is going to be a value of 0 or 0.15. I'll make a 1 minus. So this is going to be a value of 0.85 or 1. And I'll multiply the color that I've read from here by this value. So math multiply this color by the output of this and use it instead here. So let's reload the application. Okay, so when I turn on the shader, we are seeing the black bars as we're inspecting. This is rounded. Maybe the distortion is too big by default. I should do something smaller. Then on top of this, we are not really seeing the bars. That's because they are probably very, very small. So let's, we have an option here to multiply the 1. Because the values of y are between 0 and 1, more or less, this range, we have to multiply it by something bigger. And use a sign of this. Let's introduce a constant here. I'll be basically defining how big the bars are. I save it. Reload. And we are seeing the bars. At the moment, the bars are not really moving. What I do here is I introduce a time that is being added to this for doing the sign. So provided time and add. Reload the application, the shader. Okay, and the shaders are moving, but very, very slowly. So let's ramp up the time here. Infinity. Reload. We are seeing the bars going down. If I wanted to get them to go up, the multiplier of time would be negative. Okay, I hope you find this useful. Please consider subscribing and liking the video. Thanks for watching. Bye.